Hi, I'm Peter. In this video we're going to be learning all about Sir Harry Kroto, one of the university's most famous students, and all about the amazing molecule that he discovered, Buckminster fullerene. We'll also be showing you how to make your very own model Buckminster fullerene, or Buckyball. But who was Sir Harry Kroto? Sir Harry studied chemistry here at the University of Sheffield in the 1950s and 60s, doing experiments in laboratories just like this one. In 1985, he was part of a team of scientists who discovered a way to join carbon atoms together to make a new type of molecule. You might be surprised to hear that you already know about two types of carbon molecule. The first is graphite, found in pencils. In graphite, the carbon atoms are arranged in layers like this that can easily slide over each other. This means that when you grab your pencil and draw on your paper, some of the graphite layers slide off onto the page to make your picture. The second type of carbon molecule is diamond. Hard to believe it's made of the same tiny carbon atoms as graphite, given that it looks and feels so different. But in diamond, the carbon atoms are arranged in this regular criss-cross pattern, making the molecule really strong, and that makes diamond one of the hardest materials on Earth. In the new carbon molecule that Sir Harry and his team discovered, 60 carbon atoms were joined together to make a hollow ball shape, made up of 20 hexagons and 12 pentagons, just like the panels on a football. They named the molecule Buckminster fullerene, after an American architect who designed buildings using the same pattern. We now call it the Buckyball for short. The Buckyball molecule is really small, 1 nanometer or 1 billionth of a meter across. You hopefully learned all about scale in our first video, but a handy way to think about it is that the jump in size down from the whole Earth to a football is about the same as the jump down from a football to the Buckyball molecule. Now you've learned all about what a Buckyball molecule is, let's have a go at building one. Step 1. You'll need to open up your Buckyball kit, take out all the parts and separate the straws. It can be a bit fiddly separating the straws, but keep at it and you'll get there. The black pieces are your carbon atoms, and the white and red straws are the bonds that are going to hold those atoms together. Step 2, you're going to take 5 black carbon atoms and 5 red straws, join them together to make a pentagon. You'll need to repeat this step to make 6 pentagons in total. Step 3, you'll need to take 5 white straws to join your pentagons together in a star or a snowflake shape. Step 4, you'll need to take another 5 white straws to join the outer circle of pentagons together. At this point, it'll start to curve up and make a bowl shape. Make sure that your bowl is made up of 6 pentagons and 5 hexagons. Step 5, you'll have to do those steps all over again to make another bowl just like it. And the last step, you use 10 more white straws to join your bowls together. Make sure when you do this you create more hexagons, not any squares or octagons. And that's it, all finished. You should now have your very own Buckminster fullerene model, or Buckyball. Despite their small size, Buckyballs were a big discovery. Their hollow and stable shape means that you can trap smaller molecules inside them. This creates exciting possibilities for moving drugs around the body or for trapping and destroying toxic substances. Buckyballs and other nano-sized particles even have possibilities for making computers faster or for designing new types of rocket fuel. Over 30 years after their discovery here on Earth, Buckyballs have even been found in space, out of this world. The initial discovery of the Buckyball was so important that in 1996, Sir Harry was awarded the Nobel Prize in Chemistry. Sir Harry was always really passionate about inspiring the next generation of young scientists, and he ran Buckyball workshops all over the world, in India, China, Malaysia and Japan. Sir Harry sadly passed away in 2016, but we're sure he would have been delighted that you're watching this video and learning all about science by building your very own Buckyball. If you enjoyed this video and want to find out more about molecules and the exciting things you can do with them, check out the next video about polymer slime and bath bombs. And if you missed it, why not go back and watch our first video on scientific scale.